Hey everyone, it's your soft-spoken scientist. Today we're going to be working on a general chemistry lab 1, and we're going to be doing it the right way. In this lab, we're talking about measurement, density, and lab reasoning. So let's get started. In chemistry, we don't pretend measurements are perfect. We report what the instrument allows us to know, no more, no less. We know mass is measured in grams, which is known as G. Volume is measured in milliliters, which is ml. Temperature is measured in degrees Celsius. In the ideal gas law, do you guys remember what temperature is measured in? Kelvin. So if you watch my video, you guys would know that. So these units are standardized, so results can be compared between experiments. So let's look at a practice problem. Okay, we have two students measure the same liquid. Student A uses a beaker and records 25 milliliters. Let me stop you guys. What do you guys know about beakers? We know they're like thick, fat cups, right? You'll see them in your lab. They're mainly used for holding and mixing, definitely not precision. Student B uses a graduated cylinder and records 25.6 milliliters. Which measurement is more reliable and why? What do you guys think? Wouldn't it make sense that if I want to know which one's more reliable, has the most accurate reading of the fluid within the instrument, I'm gonna think it's student B, because student B. The graduate cylinder has finer scale markings, so precise volume readings. All right. Hopefully that wasn't too bad. Now, as we move on, we're gonna do part 2, which is significant figures and why they exist. Significant figures are not arbitrary rules. They prevent you from lying with math. Here's the core principle I need you guys to know. You cannot report more precision than your weakest measurement, all right? If your volume is only known to the nearest tenth, your final answer cannot magically be more precise. So let's do a practice problem. Look at question 2. A sample has a mass of 10.432 grams, a volume of 2.1 milliliters. How many significant figures should the density have and why? So let's count this together. We have 1, 2, 3, 4, 5. We have 5 sig figs. Here in the volume, we have 2 sig figs, right? The final answer must have 2 significant figures because the volume measurement limits the precision of the calculation. Usually, that's one reason. But another reason is I want my answer when I find my density. I want it to have the lowest amount of sig figs possible. I don't want the maximum, and 2 is less than 5. All right. So, how many significant figures should the density have? 2. And again, volume measurement is going to limit precision of calculation. Easy and simple as that. All right. Let's try question 3 next. All right. So before we do, I want to explain something to you guys. So density tells us how tightly matter is packed. Higher density means more mass in the same space. Okay, so this is some things that you need to know about density before you start tackling it. Density is equal to mass over volume. So if I have mass divided by volume, which is grams over milliliters, I know that this is the unit for density, grams over milliliters. And I want you guys to know, again, the higher density means more mass in the same space. Okay. A metal has a mass of 36.2 grams, a volume of 13.5 milliliters. Calculate the density and explain what the value means physically. So let's do the calculation. But before I do, I'm going to say, how many sig figs should I expect my answer to have? I have 1, 2, 3. 1, 2, 3. So I need 3 sig figs. That's the lowest I can have, so I'm going to aim for 3. So you want to take the density and say it's mass over volume, so 36.2 divided by 13.5. And when you plug that into your calculator, you're going to get a big number, 2.681, blah, blah, blah. But I only need 3 sig figs. I got my 2, I got my 6, and I got my 8. I don't need to round anything up. So, but the final answer is 2.68 grams per milliliter. That I calculated the density. So, here's what you guys need to know, because they wanted us to explain what the value means physically. So if density is that, and water density is 1 gram per milliliter at 4 degrees Celsius, I'm telling you guys that because you're going to need to know it. I know that the density is greater than water. And I want you guys to understand, if an object's density is greater than water, aka greater than 1 gram per milliliter, you're going to sink. If an object's density is less than 1 gram per milliliter, you're going to float, right? So a density of 2.68 grams per milliliter means every milliliter of this material has almost 3 grams of mass. That's denser than water, so this object would sink. Good job. Now, we're going to move on to water displacement. Displacement works because matter occupies space. If an object enters water, it pushes water out of the way. So let's take a look at this. An object is placed in water. The initial volume is 20. Final volume is 27.4. The mass is 41 grams. Find the density and explain why subtraction is necessary. We got this, right? So density is your mass all over your volume. But I got a final and initial volume. I need to find the object volume first and foremost. The formula is to take the volume final minus the volume initial. Go from where you ended to where you first began. So let's take a look. We have 27.4 minus 20.0, right? That would get me 7 point, well, I know that the rule for sig figs are different with addition and subtraction. How many numbers do I have after the decimal point? I got 1, and I got 1 right here. It's just 1, right? So I would say 7.4 milliliters. Let me change a different color, I know. So the object's volume is only the water it displaced, not the total water in the cylinder. So I'm going to take 41.0 grams. Congratulations, I found my volume. I'm going to plug it in. So 7.4 milliliters. My units are looking good, so I know I set this up correctly. So I'm going to say density is 41.0 grams divided by 7.4 milliliters. And I'm going to get 5 point, and when you plug it into your calculator, 41.0 divided by 7.4, you're going to get 5.54, right? I only need 3 sig figs, so I'm just going to say 5.54 grams per milliliter. And then again, but guess what? The 7.4 was still a process that we were using, which was 2 sig figs. So I'm not even done. I'm going to say 5.5 grams per milliliter. This is my answer, not 5.54, because this is 2 sig figs. And I knew it was 2 sig figs because of that. All right, good job. Let's move on to question 5. An unknown liquid has a density of 0.88 grams per milliliter. Is it more likely water or ethanol, and explain? So this one's a bit of a doozy. I know that the density is, you guys, is this density more or less than water? It's less than water because it's 0.88 is less than 1 gram per milliliter, right? So it's more likely gonna be ethanol because its density is lower than water. And understand, density is a characteristic property. So density does not depend on sample size. All right? Okay, let's talk about part 6, which is error analysis and why labs care. All right? So here's a formula you guys need to know. Percent error is the absolute value of the experimental minus the accepted, all over the accepted times 100. Okay. Percent error quantifies how far your measurement is from the accepted value. Let's try question 6. Okay. We got an experimental value of 2.30, an accepted density of 2.50. Calculate your percent error and explain what it tells you. So let's look back at our formula, right? Experimental minus accepted first. So you got 2.30 minus 2.50. So when I start with that, and I would get 2.30 minus 2.50. It's, in all actuality, negative 0.20. But everything in an absolute value has to be positive. So just flip it, boop, and your answer is just 0.20 on that, right? I need to divide by the accepted. What's my accepted? 2.50. So when I divide by 2.50 and I multiply it by 100, I'm going to get 8.0%, which is 2 sig figs. Boom. So I have 8.0%. So the answer is 8.0% error, which means the measurement is reasonably close, but shows experimental limitations, which would make sense. It's not the worst lab in the world. So let's move on to part 7 that I wanted to share with you guys on. Most lab 1 points are lost because students, overround, forget units, ignore sig figs, report unrealistic precision, and they don't explain reasoning. So just try to avoid that. Let's check this problem out. A student reports a density of 4.987654 grams per milliliter using a graduated cylinder. Is this scientifically reasonable? Why or why not? No, of course it's not, right? So let's write this out. So no, because the reported precision exceeds the instrument's capability. It doesn't even, when y'all go to lab, it does not have that nitty-gritty specific detail on it. It's just impossible, Precision must reflect the tool, not the calculator. Gen Chem 1 lab is about learning how to think, measure, and explain like a scientist. If you can justify your answers, not just calculate them, you're setting yourself up for success. I hope this video has helped you guys. Please hit that like button. Please hit that subscribe button. And remember, STEM is for everybody, especially you. Thanks, guys.